In this particular question, we are provided with a complex number 1 over 3 minus 4i, and we have to express it in the standard form. So standard form will be a plus ib. Now since we have the complex number in the denominator, in order to be able to write it in the standard form, we have to take it to the numerator. The procedure to do this is, so we first write down the given complex number, which is 1 over 3 minus 4i. Then we go to the denominator and find its conjugate. The conjugate of the denominator will be 3 plus 4i. So we take that conjugate and multiply 3 plus 4i to both the numerator and the denominator. So that should give us 3 plus 4i in the numerator, and in the denominator we multiply 3 minus 4i to its conjugate, which is 3 plus 4i. Now this denominator, the product is of the form a minus b multiplied to a plus b. Now that is an identity which is given by a squared minus b of squared. So we will apply the identity, so that should give us 3 squared minus 4i whole squared. So we have 3 plus 4i divided by 3 squared is 9 minus 4 squared, which is 16, times I squared. That is equals to 3 plus 4i divided by 9 minus 16 times negative 1, since we know that the value of I squared is negative 1. So this gives us 3 plus 4i divided by 9 plus 16, which finally gives 3 plus 4i divided by 25. Now we have the complex number in the numerator, so let us write it in the standard form. So this will be 3 over 25 plus I times 4 over 25. So it's in the standard form, so the value of a will be 3 over 25 and the value of b will be 4 over 25. Let's do another one. In this question, we have a complex number 5 plus 4i, which is divided by another complex number 4 plus 5i, and we have to express it in its standard form. So we begin by the same method. We first write down the given expression, which is 5 plus 4i divided by 4 plus 5i. Then we look at the denominator, which is 4 plus 5i, and we try to find out its conjugate. The conjugate of 4 plus 5i will be 4 minus of 5i, and we multiply it to both the numerator and the denominator. So now we have 5 plus 4i multiplied to 4 minus 5i in the numerator divided by 4 plus 5i times its conjugate, which is 4 minus 5i. Now we have to find the product of both the numerator and the denominator individually. So let us begin with the numerator. So we use the FOIL method. We have 5 times 4 is 20, minus 5 times 5i gives us 25i, plus 4 times 4i is 16i, minus 5 times 5i times 4i gives us 20i squared, divided by, we use the identity, a squared minus b squared, which is equals to a minus b times a plus b in the denominator. That gives us 4 squared minus 5i squared. Now we are going to further simplify it, so that gives us 20 minus 25i plus 16i minus 20 times I squared. Now I squared is negative 1, so that would give us positive 20 divided by 16 minus 25i squared. In the numerator, we add the like terms, so 20 plus 20 gives us 40. Negative 25i plus 16i will give us minus 9i. Divided by, we have 16 plus 25 in the denominator because I squared is negative 1. So that should finally give us 40 minus 9i divided by 41. 16 plus 25 is 41, and in the standard form we will have 40 over 41 plus I times negative 9 over 41. So that is the final answer. Let us do another one. So we have a complex number 1 plus I squared divided by another complex number 3 minus I. We need to convert it to standard form. Remember, the trick is to convert the denominator from a complex number to a real number. So we do that by multiplying the numerator and the denominator by the complex conjugate of the denominator. Let us begin, but first we will simplify the complex number given in the numerator, which is 1 plus I squared. We can expand it using the identity a plus b squared. We have 1 plus 2 times 1 times I plus I squared divided by 3 minus I, which is equals to 1 plus 2I minus 1, since I squared is negative 1, divided by 3 minus I. So the plus 1 and minus 1 will cancel out as they are additive inverses of each other, which will be equals to twice of I divided by 3 minus I. Now we are going to multiply the numerator by the complex conjugate of the denominator, which will be 3 plus I divided by 3 minus I, and we also multiply the denominator by the complex conjugate of the denominator, that is 3 plus I. And now we simplify. So in the numerator we have 2i I plus times 3 is 6I plus 2i I plus, times I is 2I squared divided by 3 squared minus I squared, which will give us 2I squared will be negative 2 plus 6I divided by 3 squared is 9, and I squared is negative 1, so we have plus 1. So that finally gives us negative 2 plus 6I divided by 10, which is equals to negative 2 over 10. After simplification, we should get negative 1 over 5 plus I times 6 over 10, which in the simplified form will be 3 over 5. So this is the standard form of the given complex number. Let us do another problem. So we have to express the given complex number in its standard form. Let us first begin by finding the product of both the numerator and the denominator separately. So we have 3 times 2 is 6 plus 3 times 3i will give us 9i minus 2i times 2 will be 4i minus 6i squared. That's what we get in the numerator, divided by the denominator, which will be 1 times 2 minus I is simply 2 minus I, plus 2i times 2 is 4i minus 2i times I is 2i squared. Let us replace I squared by negative 1, so we have 6 plus 6 in the numerator, so the real term will be 6 plus 6, which gives us 12, plus 9 minus 4i gives us 5i, divided by, we have 2 minus of 2i squared, so I squared is negative 1, that will make it positive 2, so 2 plus 2 will be 4, plus 4i minus I will be simply 3i. Now we're going to multiply the numerator, which is 12 plus 5i, by the complex conjugate of the denominator, which is 4 minus 3i, and we also have to divide it by 4 minus 3i, and it's multiplied to the given denominator, which is 4 plus thrice of I. Now let us multiply it. So this gives us 12 times 4 is 48, minus 12 times 3 is 36i, plus 5 times 4 is 20, minus 5 times 3 5i times 3i is 15i squared, divided by 4 squared, which is 16, minus 3i squared, which is plus 9. So we have 48 minus 15i squared, which is simply 48 plus 15, so that would give us 63, and this is a 20i here. 36 minus 36i plus 20i is negative 16i, divided by 25. So we write it down in the standard form, so that would be 63 over 25 plus I times negative 16 over 25. So this will be the standard form. Let us do another problem. In this question, we have to express the given complex number in its standard form. So let us begin by first simplifying the denominator. We have -2 plus square root of -3. Now square root of -3 can be rewritten as square root of 3 times -1. So we have square root of 3 multiplied to square root of -1. Now we know the square root of -1 by definition is iota. So we replace square root of -1 by iota multiplied to square root of 3. So our expression, our complex number in the denominator will simply become -2 plus I root 3. Now we're going to multiply and divide the given expression by the conjugate of the denominator. So that would be -2 minus I times root 3 divided by -2 plus I root 3 multiplied to -2 minus of I root 3. So we have -2 minus I root 3 in the numerator divided by -2 whole squared minus square root of 3 times I squared. So that should give us -2 minus I square root of 3 divided by -2 squared is 4. Then square root of 3 whole squared is 3 and I squared. So we have -3I squared, and then we can substitute I squared with -1. So that makes it 4 plus 3. So we'll have 7. Then finally we have -2 over 7 plus I multiplied by square root of 3 divided by 7. So this is the final answer, and we have expressed the given complex number in its standard form. Let's go to the next question. In this question, we have to express the complex number 1 plus I multiplied to 2 plus I divided by 3 plus I in its standard form. So let us first find the product in the numerator, product of the two given complex numbers. So we have 1 plus I multiplied to 2 plus I. So that would give us 1 multiplied to 2 is 2 plus 1 multiplied to I is I plus I multiplied to 2 gives us twice I plus I times I is I squared divided by 3 plus I. So we have 2 plus I plus 2I is 3I plus I squared is -1 divided by 3 plus I. Then we combine the real parts, so 2 minus 1 will give us 1 plus 3I in the numerator divided by 3 plus I in the denominator. Now we multiply both numerator and denominator by the complex conjugate of the denominator, which will be 3 minus I. So we have 1 plus 3I multiplied to 3 minus I divided by 3 plus I multiplied to 3 minus of I. Now we find the product in the numerator. So we have 1 times 3 minus I, that is simply 3 minus I, plus 3I times 3 is 9I, minus 3I times I is 3I squared divided by 3 squared minus I squared. So we have 3. So minus of 3I squared will be plus 3 plus 9I minus I will give us 8I divided by 3 squared is 9 minus I squared is -1. So negative times negative will give us +1. So finally we have 6 over 10 plus I times 8 over 10, and we can further simplify it to get 3 over 5 plus I times 4 over 5. So this is the given complex number in its simplified form. Let us do another problem. So we have a complex number given by 2 plus I whole cubed divided by 2 plus 3I. So we have to express it in its standard form. So first let us expand the complex number in the numerator. So we have 2 plus I cubed. So we'll apply the identity that A plus B whole cube is equals to A cubed plus 3a squared b plus 3ab squared plus b cubed. So that gives us 2 cubed plus 3 times 2 squared times I plus 3 times 2 times I squared plus I cubed divided by 2 plus thrice of I. So we have 2 cubed gives us 8 plus 3 times 2 squared, which is 4. So 3 times 4 is 12. 12 of I. 3 times 2 is 6. And then we have I squared, which is negative 1. So we'll have negative 6. And I cubed is simply I squared times I, which gives us negative I. So we have negative I divided by 2 plus thrice I. Now let's combine the real parts. So we have 8 minus 6, which gives us 2, and 12i minus I is simply 11i divided by 2 plus 3i. Now we're going to consider the conjugate of the denominator, which is 2 minus 3i, and multiply it to both the numerator and the denominator. So let us further simplify, and this should give us 2 times 2 is 4, 2 times negative 3i is negative 6i, 11i times 2 is 22i, and 11i minus 3i is negative 33i squared divided by 2 squared minus of 3i whole squared. So we have 4 minus 6i, so let's write it down as 22i minus 6i plus 33, I squared is negative 1, divided by 4 minus 9i squared. 4 plus 33 will be 37 plus 22 minus 6 is going to be 16i divided by 4 plus 9, which is 13. So the final answer will be 37 over 13, which will be the value of A, plus I times 16 over 13, which will be the value of B. So we have the given complex number to simplify and written in its standard form. Let's go to another one. We have the complex number 1 minus I divided by the complex number 1 plus I, and we have to express it in the standard form. So let us begin by writing down the given complex number. So we have 1 minus I divided by 1 plus I. Now we're going to take the conjugate of the denominator, which will be 1 minus I, and we're going to multiply it to both the numerator and the denominator. So we have 1 minus I whole squared in the numerator divided by 1 squared minus I squared in the denominator. Now we expand the numerator using the identity a minus b whole squared, which is 1 minus 2i plus I squared divided by 1 plus 1, which is equals to 1 minus 2i, I squared is negative 1 divided by 2. So 1 and negative 1 cancels out, leaving us with negative 2i over 2, which is equals to negative I. And in the standard form, we have 0 plus I times negative 1. So the A value is 0 and B value is negative 1. Let's go to the next question. So let us begin by first expanding the complex number given in the denominator. So we have 2 squared plus 2 times 2 times I plus I squared. And that gives us 1 over 4 plus 4i minus 1, which will be equals to 1 over 4 minus 1 is 3 plus 4i. Now we're going to take the simplified complex number 1 over 3 plus 4i, and then multiply both numerator and denominator by the complex conjugate of the denominator, which is 3 minus 4i, and that gives us 3 minus 4i times 1 is 3 minus 4i in the numerator, and in the denominator we have 3 squared minus of 4i squared, which will be equals to 3 minus 4i divided by 9 minus 16i squared, which will be 9 plus 16. Therefore, finally, we have 3 over 25 plus I times of negative 4 over 25. So this is the complex number 1 over 2 plus I whole squared expressed in the standard form. Let's do another one.